Alright, so we're going to show you some related rates problems and then explain the steps to solve the related rates problem.
So first you use, just like showing when you use related rates. So use it like when you're giving one rate and asked to find another. And when we say rates, we mean derivatives. That's usually what a rate is. And so these problems have to do with derivatives to find the other rates. And they're usually used with geometry, like both 2D and 3D, and you use geometry formulas to help you in the problem.
The first step to solving a related rates problem is to understand the problem. First you need to figure out the different derivatives that will occur once you derive the geometry formulas.
And it's what's being asked in the problem, what you're trying to find.
The next step is to develop a mathematical model of the problem. Often that will be like a geometrical formula, of a shape or of something like that. So drawing a picture will really help you in this step.
Just do anything that will help you better understand the problem.
Next, you write an equation that relates to different variables within the problem. And like I said, that's usually a geometry formula. And then next, you differentiate that formula implicitly with respect to time.
That means you take the derivative of each variable and have it respect to time. And if you don't know what the derivative is, then you just leave it as derivative of thing over dt. And yeah.
Next, you substitute values in for the different quantities that change within the formula. And then you solve for the different derivatives and use those to relate the different equations. And so then you solve for the unknown rate that you're asked to solve for in the problem.
Okay, so we have a problem to show you. Okay, this balloon is being inflated and its volume is increasing at a rate of 768 pi centimeters per second. When the radius is 8 centimeters, how fast is the surface area increasing? So first, when we see the word rate, we're thinking derivatives. And so that's the first derivative we can find. And we are given that the radius is 8, so we're trying to find the derivative at a given point. So first, let's draw a picture. So there's our balloon.
It's spherical. We didn't put that in the problem, but that is what it is.
And then, so the radius right now is 8, so let's put that right there. And then V equals, dV dt, which is the rate of the volume, equals 768 pi. So let's use a few formulas to find how we can use dV dt and the radius. So first, the volume of a sphere is 4/3 pi r cubed. And we're also supposed to find the surface area. And the surface area, which we'll just label as S, equals 4 pi r squared. So first we're going to set up the volume equation. So let's take the derivative of the volume. So dV dt equals 4 pi r squared dr dt. Remember the chain rule and the dr dt, and when you take the derivative of r cubed, the 3 comes down and multiplies with the 4/3, and the 3 cancel, so it just leaves 4. You could write it as 12/3, but we just left it as 4. And then just remember to do the dr dt, because you have to do the chain rule. And
inside.
Yeah, so the derivative, think of it as r parentheses cubed. So you take the derivative of that, then it'd be dr dt times r squared. So we're going to go into the next page so we have more room. So I'm going to write that equation one more time. dV dt equals 4 pi r squared dr dt. And since we know dV dt and r, we're going to substitute those in. So 768 pi, actually I'm going to bring that down. 768 pi equals 4 pi, and we also know the radius, so we'll substitute that in, and it's 8, so 8 squared is 64, so 64 times dr dt. And we're going to solve for dr dt, so we can also use that to find the surface area. So when we take the derivative of surface area, it'll be ds dt equals 8 pi r dr dt. And so we're trying to find dr dt so that we can use it to find ds dt. So 768 pi equals 4 pi times 64 times dr dt. So we can cancel out the pi's, and we can just divide pi by pi on each side, and those will cancel out. And then we divide by 4 and 64, and then we find that dr dt equals 3 centimeters per second, because remember, it's a rate. And next we're going to use this to find the surface area. So from what we wrote in the last one, remember to do the chain rule and just use that again. It's just the same way as doing the volume one. So ds dt equals 8 pi r dr dt. Right? Yeah. So we know the radius and dr dt, so we can substitute those in to find the surface area. So ds dt equals 8 pi times 8 times 3. So ds dt equals 64 times 3 times pi. So ds dt equals 192 pi. And that's our answer right there. And remember, it's a rate, so centimeters per second. Yeah. So just some final points. Just remember to use these steps. It really helps. And if you need to draw a picture to help you understand that, that's a good thing, just as long as you understand what you're trying to find. So also when you're reading the problem, just try and see, what am I given here? What am I trying to find? And what can I do to find it? So when you're given like geometry things, just think formulas. Trying to think of formulas where you're given different values and different things that you can solve for. And remember to do, when you're doing the derivative, remember, solve with respect to time. Respect to time. And solve and do the chain rule, like right here. And make sure to take the derivative of the inside as well. And do you have anything else?
No, that's good.
I think that's it. So if that helps, that's great. If not, watch it a couple times if you want, if you need to. But just good luck.